Hello, and welcome to another lesson on rational functions. In the last lesson we looked at some graphs and kind of just what they look like to get some idea of what we're talking about. And in this lesson, this particular lesson will be done in two parts from this analyzing rational functions step-by-step document. We're going to look at how to find the characteristics of rational functions when we just have an equation, basically, when we don't have the graph. I thought it might be helpful for you to have looked at the graphs before so you had an idea of what do these things look like that we're finding when we're using equations. So, again, rational functions are functions that are created, rational meaning fractional. They have a fraction. They're made up of a ratio. It's a ratio of two polynomials. And some things become interesting, like, the zeros of the polynomials become very important. So here are the characteristics we need to look at. As always, the domain. And the domain here is no different than the domain we've been doing before. Since they're polynomials, there's no square roots or anything in them, but you need to look at the zeros of the denominator of the function. And those are numbers that make that zero, values of x that make the denominator zero, are excluded from the domain. Vertical asymptotes, these are going to be related to the domain. These, first thing we're going to do is find the domain, and then we are going to look at the zeros of the top, and using the zeros of the bottom, which tell us what can't be in the domain, and the zeros of the top, we compare them. And if there are any numbers that are in both of those lists, we cross them out because they are not vertical asymptotes. But other than that, what you can't put in the domain generally makes a vertical asymptote unless it also makes the top zero. We're going to look at finding the zeros of a function. This is related to the zeros of the numerator. I'm just going to write top because I'm still not too good at writing with this pen yet. Okay? So vertical asymptotes, zeros would be where you cross the x-axis. Vertical asymptotes would be those vertical lines you don't cross. Holes, that would be a case where it looks like the graph goes through, but it's actually a missing point in the domain. And then in the next video, we will look at horizontal asymptotes, and we're actually not going to look at slant asymptotes in this course right now, but they are also included in this list of notes at the bottom if you were interested in those. All right, so any of characteristics 2 through 6 may or may not be present in a rational function. You might not have any zeros. You might not have any vertical asymptotes. You might not have any holes. You might not have any horizontal asymptotes. But we're going to see how you find that out, basically. And I think the way I want to teach this is with an example. So we're going to use this example where our top polynomial right here is x squared plus 5x plus 6, and our bottom is 3x squared minus 27. Here are the steps we're going to take to answer the first 4 questions above. We'll handle question 5 in a separate video, but we can get the answer to the first 4 characteristics by doing a set of steps and then looking at the results. So the first thing you're always going to do when you're analyzing a rational function is take the function that's at the top. This is my x squared plus 5x plus 6. There you go. And find its zeros by solving this equation. Typically, we solve this by factoring if it's a quadratic, and you can, or you could use the quadratic formula. This is why we spent some time solving quadratics in class. So you can do this. You can always use the quadratic formula if you're not good at factoring. But and if factoring doesn't work, you need the quadratic formula. But here, this one factors. X squared plus 5x plus 6. I want to find the zeros of the top of this polynomial, of this rational function. So x equals -2 and x equals -3 are my two zeros of the top. And then I do the same thing for the bottom. I find the zeros of the bottom. I have to factor this. The first thing you do is factor out a common factor. Now, I could have done this a couple of other ways because of the type of quadratic it is. I could have used the quadratic formula, but I saw that I take a greatest common factor out, then I have the difference of 2 squares. So these are the zeros of the bottom. So what I have is the zeros of the top. So we're finding the zeros, and the zeros of the top where x equals -2 and x equals -3. And the zeros of the bottom where x equals 3 or -3. I make that list. Now I'm going to use this list to answer the questions. The first question is, find the domain. The domain can be anything except the zeros of the bottom. So x cannot be 3 or -3. And this is how I leave out the -3 and leave out the 3 in interval notation. On written test for me, this is fine. My math lab is going to want this notation though. So in words, x is all real numbers except 3 or -3. So if that's what you show on your work, that will be good too. Then I find the vertical asymptotes. I again look at this list of zeros of the bottom. That's potentially my vertical asymptotes, but they might not all be vertical asymptotes. So the reason it might not be a vertical asymptote is if one of these shows up in two lists. Look at that. X equals -3 is the zero of the top and the bottom. That means it won't be a vertical asymptote, nor will it be a zero, but it'll be a whole. So I cross that out of my list of vertical asymptotes. I basically list all of the things that aren't in the domain, and I'll cross out -3 from my list of vertical asymptotes because it's also a zero of the top. But I'm working again from that list. The first thing I do is I find the zeros of the top and the zeros of the bottom. So when I'm asked about vertical asymptotes, I looked at the zero of the bottoms. Okay, there are my choices. Uh-oh, -3 is up here too, so I'm going to cross that out as far as being a vertical asymptote. Then to find the zeros of the x-intercepts actually is what you're finding of the function. You look at the zeros in the numerator. Those are your potential x-intercepts. If you're going to have an x-intercept, it's going to be at least one of these, is at one or both of these points, but it might not be at both. Again, that -3 is a zero of the top, but it's not a zero of the function because it's also a zero of the bottom. So you only have an x-intercept at x equals -2. So that's how you find your zeros. Zeros of the top that aren't also zeros of the bottom. So now, what do you do with that -3? Must be some significance. Well, it is. You don't see it on those graphs you do with technology for sure. It looks like this function passes straight through x equals -3 if you graph it. But x equals -3 is a zero of both the top and the bottom. So it's not a vertical asymptote, and it's not a zero of the function, but it is what we call a whole. It's a whole, and you cannot calculate a function value at x equals -3, because if you go back to your original function, if I put an x equals -3 there, I get a +9 when I square it. I get 20. I get 0. I'm dividing by 0. So you can't graph a y-coordinate for x equals -3. So that makes a hole in your graph. All right, so those are the things I wanted to talk about in this video. The first thing you need to do, and you should be better at this by now because we just went through solving quadratics, and if I give you more than a quadratic, I'll likely give it to you in factored form already. You find the zeros of the top, find the zeros of the bottom, and then you go through and analyze. Find the vertical asymptotes. Occur at any zeros. The domain is straight out. The zeros of the bottom are not in the domain. Then the vertical asymptotes are a little trickier. You look at the numbers that aren't in the domain, but you have to cross out any that also make the top zero. That'll give you your list of vertical asymptotes. And the equation of a vertical asymptote is x equals a number. Whoop, sorry, I made that disappear. Let me see if I can get it back. There we go. Sorry. I like technology sometimes. So the equation of a vertical asymptote, it is a vertical line. So x equals 3 is your vertical asymptote. Your zeros occur at x equals -2 or at x equals -2 or the point -2, 0. That's a point. And the holes are also points, but you just give the x location of it because there is no y coordinate. It's not really a point. It's where it occurs is at this x value of -3, and that is any number that gives you a zero of both the top and the bottom. Now you can see that if you didn't have any zeros that occurred in both the top and the bottom, you wouldn't have any holes. And if you didn't have any zeros of the top, you wouldn't have any zeros. And if you didn't have any zeros at the bottom, you wouldn't have any vertical asymptotes. That's how to find vertical asymptotes, zeros, and holes. And that is all I have for this video. In the next video, I will explain how to find horizontal asymptotes. Thank you.